Hello everyone, I am a tutor with UPlads and today we are going to learn about some basics of SQL. Even before querying, we need to understand this language, the basics of language, the purpose of it. So that is going to be the overview for today's lecture. To start with, we are going to discuss about what is SQL, what can SQL do. We are going to give a brief introduction to RDBMS, which we talked about in our previous lecture. We are going to talk about SQL and its process, asset property that every database follows. We are going to talk about the ER model and relationships. This will give us a very brief idea about how exactly our database is being maintained, how we are supposed to look at the data. We'll get a brief idea about this. And last but not the least, we are going to talk about database normalization. Why is it necessary? And what is the purpose of using normalization technique in our databases? So, to start with, what is SQL? It is SQL basically stands for structured query language. SQL lets you access and manipulate databases. So as we talked about database in our last lecture, uh, to access the database, we need to learn a language or we need to talk to database. For that, SQL is the language. And what does SQL do is that it will help you access that database. And if you want to change some records in it or you want to insert new records in it, then that also is possible using SQL. This language, as I have already mentioned, it is used to retrieve, update, modify, delete, or insert any new information in database. It is the standard language for all the RDBMSs, so that is relational database systems. But there are various different systems available, such as MySQL, MS Access, Oracle, Sybase, Informix, Postgre, and SQL Server. But they all use SQL as their standard database language. So as we know that there are so many platforms, the communication language still remains the same. It's only a few syntactical changes which has to be done to your query. Apart from that, the basic standard still remains the same if you want to access data on different platforms. So what can SQL do? It allows users to access data in the relational database management systems. It allows to describe the data. So let's say I am new to a company and I want to know that how exactly the backend of this company works. I can just get access to the database. I can myself describe the data, that how exactly it is being stored. I can understand the structure of the data. So it makes very much feasible as a newcomer to understand exactly how we are going to process in the system, how we are going to process in the organization. It allows the users to define the data in a database and manipulate that data. Just as I've told you that, let's say you are working in a banking organization, and if you want to update the account balance of any particular user, you can do that if you are using databases and if you're using MySQL. But if you're using a manual file structure, then that is going to be a tedious work where you have to find the file of the user first. You have to manually see how much balance is left. You have to add yourself and you have to update the final amount into the account balance, which is a tedious work. And this is where we are using database. Allows users to create and drop databases and tables. Let's say there was some feature in my organization which is no more available and I want to drop that table. I can do that because I have access to do so and SQL allows me to do so. Apart from that, it will allow users to retrieve, insert, update, delete, create new tables. It can also help users to create views, stored procedures, functions in a database. Now, where are these stored procedures and functions used? So what happens is that in a database, if there is one particular task that has to be done every day. So let's say every day we have to check that what was the status of my user the previous day, at the end of the previous day. So in that case, I will write an automated code in the form of stored procedures or functions wherein I will be recording those, I'll be automating those transactional SQL statements so that I don't have to manually do this operational work every day. That's where we are going to use stored procedures and functions. How to use, we will definitely talk about it later in the course. SQL, it has powers to execute queries against a database or more than one databases. It can set permissions on tables, procedures, and views. Now, this can be a scenario wherein one particular table is created which I don't want anyone else in this organization to see. So I can create some permissions, some rights, so that only I can access that data and only I can modify that data. So this is the part where we were talking about data security and data privacy. So that's where SQL will be of great help to us. Moving to next. Now, just as I told you that SQL is a standard language, it is standard, but there are different versions of SQL language. So to be compliant with the ANSI standard, ANSI standard is one of the standardization language which SQL follows. But again, the problem with that is that they all support the major commands such as select, update, delete, insert, where. These are very common commands which can be used all over the platforms, on different platforms in a similar manner. It works also in a similar manner. There would be one or two maybe, or more than that, commands which are available only for a given database, while for different databases it might not be available. Okay, to start with, now we have completed what does SQL does and what is the advantage of SQL. Now, introduction to RDBMS, a small introduction of relation between SQL and RDBMS, how these both are going to be a part of our course throughout. I will give you a brief introduction for that. RDBMS stands for Relational Database Management System. It is the basis for SQL. And for all modern database systems, such as there is MS SQL Server provided by Microsoft, we have IBM DB2, we have Oracle, MySQL, which is an open software, and Microsoft Access. So for all this, the base will remain the same, that is SQL. For all the relational database systems, the base will remain the same. So if you have mastered SQL, you are very much mastered in SQL to use it on all different platforms as well. The data in RDBMS is stored in database objects called tables. As this we have already discussed, the data that is being stored, it is in the form of a table. So there is one table structure, you will find your data within it in a structural format. A table is a collection of related data entries, and it consists of columns and rows, which I have already told you, as columns are referred to as fields or attributes, while the rows are tuples or records. Moving to next. Now the SQL process. Now we have understood that what is SQL, we have understood database, we have understood RDBMS. Now let us just try to first visualize that how does our SQL query is going to be performing inside the system. So when you are executing an SQL command for any RDBMS, the system determines the best way to carry out your request, and SQL engine figures out how to interpret the task. So it is as good as I am giving one command in my language, and there is some translator in between. There is some engine in between which is translating this command into another language which is very much uh, understandable by the other end of the system. So let's say I'm talking to my friend. I can speak only one language. I'm speaking in that language. There is a translator in between, which is translating this language into the other language which my friend can understand. So that exactly is what is happening here. For SQL, they are giving some kind of command which is very much user friendly. It is more of an English structured language, so we understand the command. But how do our database understand that? So for that, we have various different components. We have query dispatcher, we have optimization engines, we have classic query engine, we have SQL query engine, etc. There are many more, but we'll discuss a few in a gist. So what happens is, once you have given your SQL query, it goes to the query language processor, where it will parse and optimize the command that you have given to the database. Now that optimized and parsed query will come to database engine. Here, this DBMS engine understands that exactly what information is required by the user. What it does, it contacts the physical database. It retrieves all that information that I want, and it will get back to us in the form of a view. So this is the basic process that would be followed, and this will be more or less the same for all the platforms. Let it be MS SQL, MySQL, or Oracle, or whatsoever. So the process will some more or less remain the same. But this is how our query is being translated to the physical database, and from there we are getting back the data. Moving to next, we have asset properties. So when we talk about databases, it is necessary that we need to understand what asset properties are. Okay, so to start with, A stands for atomicity. It makes sure that the entire transaction takes place at once or doesn't happen at all. So consider the bank example here. This example is very unique, and it would be very helpful for you to understand that what exactly these properties mean. So what is happening here is that uh, we'll talk about every property one by one. So here it is atomic. We are talking about atomicity. So what is happening is that there are two ways: either complete the transaction or just don't start it, or just go back to the original way it was. By this, we mean that either the entire transaction takes place at once or doesn't happen at all. Let's say there are 5 transactions to be carried, but there is some system failure after my third transaction. In this case, there are two things that are to be done. Either execute 2 more instructions and then commit your data, which is not possible because there was a hardware failure. So do one thing, abort that transaction itself and revert those 3 transactions also. So again, your database will be back to the position where it was originally. So hardware failure has not stopped our data loss, has not incurred data loss in our system. So which is a very good property of a database, which does not happen when you're using a file structure. By this, we mean that either the entire transaction takes place at once or doesn't happen at all. There is no midway. That is, transactions do not occur partially. Each transaction is considered as one unit and either runs to completion or is not executed at all. It involves following two operations: abort and commit. Abort means if a transaction aborts, changes made to databases are not visible. Commit means if a transaction commits, changes made are visible. So basically, atomicity is this all or nothing rule. We will do one thing, we will try to understand the example that is given to us. Now consider there are these two transactions consisting of T1 and we have T2. Here, what we have to do is we have to transfer 100 rupees from account X to account Y. So overall, my money, even if I transfer 100 rupees, I have to have 700 rupees in my bank. Okay. Considering it, this is a very ideal situation that there are only 2 accounts in my bank and I have total of 700 rupees, 500 with X account, 200 with Y account. I have to transfer 100 rupees from X to Y. My total still should remain 700. So now here, let's say if the transaction fails after completion of T1, but before completion of T2. So here, what is the purpose is that I have to transfer 100 rupees to account Y. Now let's say my 100 rupees are deducted from account X, but just before it got added to account Y, there was a hardware failure. So now the system has to roll back everything and it has to get back to the original position. That is, X should again have 500 rupees and Y should have 200 rupees. You will never see that X has 400 rupees because it got successful and then there was a hardware failure. So Y is back to 200. This will never happen because this is again inconsistency which database does not allow. So this 400 which got changed in X will again be reverted to 500 in case of failure. But if everything goes right, then after deducting 100 rupees from X account, I will have 400 rupees in my X account. And after adding 100 rupees to my Y account, I will have 300 rupees in my bank account, in my Y account, which means my total is again back to 700 rupees. That means my data is consistent. So that is what has been written here. This results in an inconsistent database state where I told you that X has 400 rupees and Y has 200 rupees. That is, if my transactions are committed partially, that will not happen in a database ka case. Therefore, the transaction must be executed in entirety in order to ensure correctness of database state. So either complete all the transactions or just do not complete anything or just do not execute anything. That's what atomicity is. Next, we talk about consistency. Now, consistency is the most important property, because when we are dealing with some important bank related data things or some organizational data, it is very much important that all your updates are consistent throughout in all your tables. So what consistency means, that integrity constraints must be maintained so that the database is consistent before and after the transaction. It refers to the correctness of a database. This is more or like similar to atomicity. Now, what we are trying to focus here is that the total amount, as I mentioned, before and after the transaction must be maintained. So before my transaction, my total was 700 rupees, 500 in X account, 200 in Y account. So my total was 700 rupees. After some transactions within the accounts, my again total should not change, which shows me that my data is consistent. And after T1 and T2, my total is back to 700, 400 in X account, 300 in Y account, which shows that my database is consistent. Inconsistency would have occurred just in case T1 completes but T2 fails. As a result, this transaction T is incomplete overall. But right now, as you can see, we have a consistent data in our table. So we are good to go with consistency. Next we have for discussion is isolation, the third property of ACID properties. This property ensures that multiple transactions can occur concurrently without leading to the inconsistency of database state. Transactions occur independently without interference. Changes occurring in a particular transaction will not be visible to any other transaction until that particular change in the transaction is written to memory or has been committed. This property ensures that the execution of transactions concurrently will result in a state that is equivalent to a state achieved. These were executed serially in some order. We will go to the example, but before that, isolation is the most important property. Considering the bank example again, let's say there is one account X and then there are two people Y and Z. Both want to transfer some amount to my X account. So in that case, what happens is that the execution of Y to X and Z to X has to happen serially. Even if it is happening concurrently, there shouldn't be any ghost read, in the sense that when one transaction, when Y was performing its action of depositing some amount to X account, it did not know that Z was doing the same thing at the same time. But that should not change the consistency of my database. In that case, all the operations should be working in isolation. And Z should only come to know that the Y has deposited once it is committed. So the changes will only be occurred in a final state in our database once it is committed. So that commit command is very much necessary for our transactions to be made visible to other transactions. So that's what we are trying to focus here. Going to the example, let's say we have X equal to 500 rupees for transaction T and we have Y equal to 500. Now consider two transactions T and T quote. Suppose T has been executed till read RY. Okay, so that means it has been executed till read RY. Then T quote starts. As a result, interleaving of operation takes place, due to which T quote reads correct value of X but incorrect value of Y. So what is happening here is that once you have read X here, you have 500 rupees. Now your value got updated, that is it got multiplied by 100. So your X has 50,000 now. Now what we'll do, we will try to write that value into our account. Okay, into X account. So now my X value is right now 50,000. At the same time, what is happening, my T quote is also trying to read the same data. Okay, so here it was 500, even here it was 500. Here my value for X changed, which got updated to 50,000. Here my value for Y changed. Y was 500 rupees, so it read 500 rupees. Again back to transaction T. It then now at the same time, it updated X to 50,000 while my Z equal to X plus Y was being performed with 500 plus 500 rupees. So here at this stage, T code does not know that X has been updated and hence it is using the old value. So what is happening here is that the T code, this particular schedule, this particular transaction is reading the correct value of X, but then it is reading the incorrect value of Y. And sum can be computed as, just take this example, T code X plus Y is equal to 50. I'm so sorry, that is a mistake. X plus Y, as I told you, it is 500 plus 500. Okay. And then it is trying to update that data. So here the thing happens is that it will not be able to read Y, because here Y was 500 rupees. Until then it came to this stage. So both the transactions were not aware of the updates that were being made because they were not committed until then. So for T code to read the proper data of X and Y, it is mandatory that the schedule T should commit the values in the database. Once that is done, we can make sure that whatever transactions that are happening concurrently are still happening correctly. So that is what isolation is about. So the basic focus of all the asset properties is that to make sure that there is no inconsistency in our database. That is the major motto of the asset property. Hence, the transactions must take place in isolation, and changes should be visible only after they have been made to the main memory. So as I told you, that it is necessary that whatever changes we are making to the database are supposed to be updated, are supposed to be committed. Only then, if you are trying to read that data, then it is correct to be read. And in that case, there will be no data inconsistency. The final property of ACID is durability. Now, this property ensures that once the transaction has completed execution, the updates and modifications to the database are stored in and returned to disk. Now, here by disk, we mean that the main memory, and they persist even if a system failure occurs. So let's say I have a bank organization. All my operations are done until end of day, and suddenly all my commits are also completed until then. That means I have already updated my database with the updated data, with the modified data. But now what happens is that there is a system failure. Now, in spite of that, durability property will make sure that my database is not corrupted or it is not left halfway. So that is where this property comes into the picture. Even if there is a system failure, my database is safe to be accessed whenever I am retrieving it from system, recovering from my failure. So the asset properties in totality provide a mechanism to ensure correctness and consistency of a database in a way such that each transaction is a group of operations that act as a single unit, produces consistent results, acts in isolation from other operations, and updates that it makes are durably stored. So basically, the only focus of asset property is around the correctness and consistency of a database, which is the need of the hour, because we cannot have our database inconsistent. Because if that is the case, then there is a lot of tedious work which is involved. And again, we are not able to solve the problem which we faced in file structure. But everything is being taken care of if we are using a database. Next, now before before starting with SQL queries, it is necessary that we visualize how our database is. And for that visualization of database, we have a ER model. Now, what is this ER model? It is an entity relational model. It is a high level conceptual data model. So exactly with this diagram, you can come to know that what our database looks like, what all data structures we are storing, what is the relationship between them. So this gives us a brief idea about our database. So ER model, it is a high level conceptual data model diagram. ER modeling helps you to analyze data requirements systematically to produce a well-designed database. So it is very much necessary, and in organizations also, what happens is that initially an architecture is created. That is, a ER model is created using which they form a database. Because this gives a rough idea that how exactly we can store our data and how systematically or in which structural way we can store our data. So this is a very mandatory step whenever we are creating a new database. So this becomes the first step to our modeling, that is ER model. The entity relation model represents real world entities and the relationship between them. In the later part of the video lecture for today, I will explain what exactly is an entity, what is a relation, what are the attributes, what are the associations. So we are going to cover this, but for now, this ER model, it just represents different aspects. So let's say there is some company, considering Amazon for us right now, we have categories, as in, was it the Amazon pantry, or was it Amazon Prime, was it Amazon fashion, whatsoever. So we have this category section here. This is one table. So one table is one entity for us, and it is something related to a thing, a place, or an event. So it is generally, why is this ER diagram used is that because it is a best practice to complete a ER modeling before implementing your database, so that you come to know that if there is some missing attribute, that is one missing column, you come to know that how do we relate them, how do we access our database. Also, if someday I want to check that how do I relate these two things together, how do I see these two things together, I need to find out the relationship between them. So from this I come to know that there is some relation between both these entities, entity product and entity product colors. So ER modeling helps you to analyze data requirements systematically to produce a well-designed database. So it is considered a basic practice to complete ER modeling before implementing a database. So ER diagram displays the relationships of entity set stored in a database. Basically, it just tells you that how are two different tables related to each other just by looking at the diagram. So we can say that ER diagrams helps you to explain the logical structure of databases. At first look, an ER diagram looks very similar to the flowchart. However, ER diagram includes many specialized symbols, and its meanings makes the model unique. So even the arrows that are being used here, they have a particular meaning to it, which helps us understand that what kind of relation they are sharing. Is it one to many? Based on cardinality, we will talk about it more later in the video. For now, the ER diagram, it helps us understand the meaning of the relation between the tables. The basic purpose of ER diagram is to represent the entity framework infrastructure. So this basically helps us understand that how our database will look once we have implemented that, and for which we have to come up with a ER diagram which shows all individual entities, that is apparel size, product colors, product color, product categories, and categories in our case, for example. And we need to show that how these different entities are related to each other. Now we can see that color and categories are not directly related, but there could be a possibility of indirect relation being built to them, between them. So that is where we need to make a very optimum ER model before implementing our database. Now there are few facts about this ER model that we are going to learn about. ER model, it allows you to draw the database design. It is an easy to use graphical tool for modeling data. As you know that it is a very much graphical design, you will be able to see it is a graphical interface of your database. It is widely used, even till date it is being used and preferred to use for our database design. It is a GUI representation of the logical structure of database. It helps you to identify the entities which exist in a system and the relationship between those entities. So every time if I want to find out the relation between two different tables, I don't have to see and check the data individually. For that, I can just come back to the ER model, refer the relationship between them, and I can go ahead and write my queries. This saves time. This is why ER model is required. Now, there are different components of ER diagram. Just as I told you while we were talking about the model relationship diagram, there are three main components. One is entities, attributes, and relationships. So as you can see, car and a person, these are entities. So basically in your database, how it will look as this person, that is, let's say customer or graduate students, that will be your one table, car will be another table. So these are entities, are basically tables to us, individual things, event, places, whatsoever. Next, move into attributes. What are attributes exactly? So attributes are nothing but columns, which I had already mentioned. So now transactions is an entity here. This transactions has different attributes. Transaction number, we have amount, we have type. Now, what are these attributes? These attributes together define the entity. So let's consider this example. Here my entity was graduate student. Let's say one of my attribute is name, and under that we have data as Jack. So I know that name is the attribute which is defining my entity. So that becomes my attribute in a ER diagram. Attribute defines an entity. Entity alone cannot be enough to understand what exactly the downlying data has in it. So that becomes attributes for use, which is basically defining your entities. Next is, we now know that there are some entities, we have some attributes that define those entities. There could be multiple such entities. Then there has to be relationships which connects two different entities. Let's say if car and entity, these are two different entities, and the relationship between them possibly could be this car belongs to Jack or probably some other person. So there is some relation between that, which can be represented using some relationship cardinality. As I told you, that what is the relationship between them. So mandatory one is basically 1 versus 1. That means there is a 1-to-1 relationship. This car belongs to Jack. Jack has this car. So there is just 1-to-1 relationship. 1 to many. Jack has many cars. All these cars belong to Jack. So that is 1 to many relationship. Jack is just one person. His association with different cars is many. That is 1 to many. Then we have optional one. That means there is a possibility Jack has just one car or Jack has more than one car. Then we have optional many, which means that there could be a possibility of having more than one. So that becomes your optional many. Next, and also there are particular symbols. As for mandatory one, this is the way we need to connect to the entities. This is the way we need to connect for mandatory many relationships. This is for optional one. This is for optional many. So for basically for many, this is the representation. And if it is optional, you have to add a circle before it. Now, we will learn about the best practices for developing effective ER diagram, because if your ER diagram goes wrong, your database is going to give you wrong output. So it's better that you have a very precise, correct ER diagram with you, for which initially the first most important point is eliminate any redundant entities or relationships. So there can never happen that two entities are repeated. That should never happen. That is the first thing. You need to have everything as unique in your ER diagram. Let it be entities or let it be relationships. It has to be a unique relationship. You need to make sure that all your entities and relationships are properly labeled. Of course, this is very much required, because what happens is that if you don't know exactly what this entity is, you have not labeled them, you will never understand that how is this related to the other entities. So it is very important that you name those entities and you also label the relationships, as in you label them which kind of relationship it shares with others. This will help you understand while you implement your database using the same ER diagram. There may be various valid approaches to an ER diagram. You need to make sure that the ER diagram supports all the data you need to store. So basically your ER diagram is a dummy database, wherein you need to check that whatever data you are desiring to store are being stored in the same format you had thought of, and not that any one of the attribute is being missed. You should assure that each entity only appears a single time in the ER diagram. This point also matches with the very first point when we are talking about eliminating redundant entities. It should never happen that a single entity is being repeated more than once. If a single entity, that is consider for example customer details, is written twice in your database, that definitely is a redundant data and is not required. Instead, a relation could have been built with the same table. Now, name every relationship, entity, and attribute that are represented on a diagram. So labeling is another important thing. Never connect relationships to each other. Obviously, there is always a relationship between two entities. Two relationships are never related, two entities are related. You should use colors to highlight important portions of the ER diagram, so that what happens is when you are presenting some ER diagram to somebody else, it should effectively show that which part you are focusing the most, but that also at the same time you need to make sure that you haven't missed out on any other. So these are few best practices you can use before implementing a database, which will give you an effective result when you see your database storing the data the way you want to do it. Now, you have, let's say, created a ER diagram, you have created a database. Now comes is we have to normalize the database. So this normalization is also taken care of when you are creating an ER diagram. But how do you understand that normalization and where it is required? That we need to understand. So what is this data normalization? Database normalization is the process of efficiently organized data in a database. Normalization takes care of redundancy. It eliminates data dependencies. So just as it is written, eliminating redundant data, for example, storing the same data in more than one table. This is redundant, that we are depending on every individual table to store every information. This makes our table more inconsistent, more prone to inconsistency. To avoid this, we have to take off every redundant data and have to make every column, row, record, and attributes unique in our database. We have to ensure that data dependencies make sense. It should not also not happen that there are two different tables, both are related to each other, but there is no common factor relating them. So that should also not happen. There should be a connection built between them. Both these reasons are worthy goals as they reduce the amount of space a database consumes and ensure that data is logically stored. Normalization consists of series of guidelines that help you in creating a good database structures. So it is not that you have to explore on normalization part. There are some rules set in database like 1NF, 2NF, 3NF. Generally 3NF is enough. Under 1NF, you will come to know that what exactly you need to do to your database or to your ER model to make it more normalized. Under 2NF, there are certain rules that you can follow to identify what kind of changes you need to make to your ER diagram to make it more normalized and more structural. So what happens is that if your data is redundant, you are just using up the main memory. And to avoid that main memory utilization, we have to ensure that we have eliminated all the redundant data. Normalization guidelines are divided into normal forms. Just as I told you about 1NF, 2NF, 3NF, think of a form as the format or the way a database structure is laid out. You have to basically follow those rules mentioned under every normal form, and you have to follow that and make the changes into your database to make it normalized. The aim of this normalization is to organize the database structure so that it compiles with the rules of first normal form, then second normal form, and finally the third normal form. So basically, it will make your database more structured. And for that structural aim to achieve, we have to normalize it with the rule set that has been given by databases. Now, in our course, we are generally we are going to use MySQL. There are many such platforms available, such as there is MS Access, there is MS SQL Server. We also have SharePoint, which is another form of database, or we have Hive. But then MySQL we are going to use for our course. It is an open SQL database. It was developed by a Swedish company. It is pronounced as MySQL or MySQL, the way you are comfortable with. It is MySQL is supporting many different platforms used, including Microsoft Windows. This is also available for Linux, Unix, MacBooks, your Mac OS, Macintosh, or and the major thing is that it has both the versions. It has versions. For our requirement, since we are going to cover majority of the basics, for us the basics of SQL that is under free version is enough. So I would suggest that before we start with the next lecture, you download and set up your MySQL server, which is available for free. And along with the MySQL server, you will also see that there is some dummy data which we will be using in our course structure. They already have some tables provided to us, which we'll be using to understand the basic SQL queries, or we will help this, will seek help of the same database to understand the assets and liabilities of SQL query language. To get back to MySQL, it is very fast, multi-threaded, multi-user, and is also very robust if used in a very correct manner. MySQL is basically used for operational databases. If you think that your data is moving towards big data, that is, a lot of data is being inserted into your table, then you probably might have to migrate from MySQL to a bigger server, until and unless you have updated your server capacities or memories. But for our course, we need not do anything of that, as we are going to learn about basics of SQL, for which free version of MySQL should be very much okay to do. Now, the advantages. I have already briefed you about the basic advantages of MySQL. Other advantages are that it has many features, stored procedures, you can make functions, you can also schedule your jobs that you are creating on an everyday basis or monthly basis the way you prefer to. It gives a very high performance based on data storage, high availability, and scalability and flexibility. It runs on anything. As I told you, that it is also linked with the Microsoft platform, so it is quite flexible enough. It has a robust transactional support, data warehouse strength, strong data protection, the security terms, as in the grant and revoke access that is available within MySQL, which will help you understand the data security part. It is very easy to manage, and it is an open source. So with 24/7 support, you can visit mysql.com. Just in case if you have some issues in downloading, you can definitely contact them. Also, lowest total cost of ownership. Generally, it happens that if you want to learn SQL, MySQL is the best way to start with, as it gives you an overall idea of how the data is, it gives you an idea in the data domain. So it is a very good step in your career. If you're starting with SQL, you may start with MySQL, as it is a little stricter form of standard SQL, which will help you create optimum and good performing SQL queries. So here is, I would like to thank you for attending this lecture arranged by UPLATS. Register for more courses. Thank you.